Hey everybody, this is Ben and welcome back to my Leetcode series. And today we're going to be working on problem 1823, which is find the winner of the circular game. So notice this is a medium problem. It is kind of a little bit of a challenging simulation at first. The concept seems really easy, and I think this problem is pretty easy to do in a long form code type of way, but making something concise can be a little bit harder. So we're going to talk through a solution today about that. So let's go ahead and get into the prompt. There are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in clockwise order. And more formally, moving clockwise from the ith friend brings you to the I plus 1th friend for 1 less or equal I lesser than n. And moving clockwise from the nth friend brings you to the first friend. So the rules of the game. 1, we start at the first friend. 2, we count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count some friends more than once. The last friend you counted leaves the circle and loses the game. If there is still more than one friend in the circle, we go back to step 2, starting from the friend immediately clockwise of the friend who just lost, and we repeat. Else, the friend in the circle wins the game. So given the number of friends n and an integer k, return the winner. So we're going to talk through a solution here. And first thing, let's go ahead and run through just this little image that Leetcode actually provides. So in this example here, we have 5 friends, as seen in the circle, 1, 2, 3, 4, 5. And our number is 2. That's the amount of friends that will count per turn. And whoever we land on, that friend gets removed from the circle. So we're going to start at the first friend. We count 2 friends, including where we start. 1, 2. Friend 2 is where we land, so friend 2 is out. And as you can see, it's not in the second picture. Now, we're going to start at the next friend clockwise from what we removed. So that means we'd start at 3, so that's 1, 2. Ending at 4, because that's the second friend. Remember, k equals 2 in this case, so we remove 4. Now, we start at 5, 1, 2, remove 1. Now we start at 3, 1, 2, remove 5, and 3 is the last thing in our circle, so that's the winner of the game. So let's talk through the example in a little bit more depth here, and I'll explain to you my solution. So for that first example that we just looked at, when n equals 5, the amount of friends, and k equals 2, the amount of friends we count per turn. So remember, we always start at the first friend. This is equal to the value of 1, which is at the index of 0 in our array list. So for our first iteration, that's where we're starting. Now we simply need to count k friends, including the starting index, and we'll remove the kth friend. So note, once we remove the kth friend, our new starting index remains the same because all elements after the removed element shift forward post-removal. So that's kind of the logistics around the data structure we're going to use here, which in this case will be an array list, so I'll explain that more in a minute. Since the friends are sitting in a circle, we have to manipulate a data structure to act like a circle. In this case, we'll use an array list. I found that to be the easiest. If our calculated starting index is greater than list.size minus 1, the last index in our array list, then we need to loop back to the start and continue our count up to k for the current iteration. We can use additional loops to count our starting index up to k. I originally did that, and then I found a more concise solution that I really like. So I decided to use that once I came up with it. Now we need to initialize the starting index as 0. We say that the index is to remove is equal to the starting index plus k minus 1. So that's the equation that I came up with that is going to be a little bit more concise than using for loops. The negative 1 in this equation is needed to calculate our offset because we're counting the starting index element as part of our k friends of the turn. So if we didn't have the negative 1, we'd be going 1 too far. Now you can, scrolling sideways, you can manually do the same thing using a for loop. I just like the simpler alternative. Now when we remove the index in question, we restart this process until the list size equals 1, which means we have a winner of our game. So let's go ahead and run through an example here. And actually going back really quickly, so remember, it's possible that when we say index plus k minus 1, that we go out of bounds. We calculate an index that is beyond our list size, so we can't use it. So in that case, we'll use modulo, which gives us the remainder. What we can do is take our index that is out of bounds, and we can circle back to the front of the equation with modulo, because that finds us the remainder. So let's go ahead and talk through that. So first, in our pseudocode, we need to add all our elements 1 to n in an array list. We set our index to 0, and while list.size is greater than 1, we add k-1 to our index. We check, is our index greater than our list size minus 1, which again, that's the last index in our array list. If yes, we can take our index and we can set it equal to index modulo list size. Because what that will do is, let's say we have an index of 4 and our list size is 3, we'll get 1 as our remainder. So if we're trying to count up, let's say we just had, I guess this would be index 2 plus k-1 would be 2. That gives us 4. What this will do here when we use modulo, it simulates that wrapping around effect. So it's going to find the index equivalent to 4 that's within bounds, basically. So go ahead and remove that. Now, no matter what, if our if statement catches or not, we'll remove the index from the list. And then we can return the only element still in our array list, which is a 0. So let's go ahead and code up a solution together. So I'm going to start with creating our array list that we're going to use. I'll just name it L. Now we're going to use a for loop to fill this. So remember, I need to set I to 1 because we're starting at friend 1. And I'll say I less than or equal to n I++. This will populate our array list. We'll go ahead and L.add I. Now going down, going to create an integer variable index. So this is crucial to our solution, and it's going to track our index. And I need to switch this up here. Now what we're going to do is we're going to set our index plus equals k-1. So that just means index equals index plus k-1. This little operator here is just a little more concise way of saying that. Now if our index is greater than L.size, what we'll do here, L.size minus 1, excuse me. What we'll do here is we'll set index equal to index modulus L.size. Because remember, when we go out of bounds, this will take us back to an index that is within bounds. So it will simulate that counting of k, right? Counting up to k. So if we're counting, if we're already at the end of our array list, let's say our array list size is 3, and we're at index 2, and we need to count 2 more friends, instead of going resetting 2 to 0 and then 0 up to 1 and things like that, what we can do is just go ahead and add up to 4, and then we can modulus 3, and that gives us 1. So it just gets us to that same point a little bit faster. And then we'll L.remove index. So remember, everything after what we're removing will shift forward. That's why our index can remain the same in our next iteration. Now at the end, this will break when we have only one element in our list, so we can return L.get 0. Let's go ahead and run the code. So as you can see, for our test cases, this worked very well. Now getting into our submission details, this isn't the fastest solution that I was able to come up with. As you can see, I was at a couple 6 millisecond submissions, and what I actually did for those is I just used a for loop to count rather than this. I used a for loop, incrementing index while another variable was less than k, so I'd count up to k. And once index was greater than our list size, I would just reset to 0 and continue that process. So that technically came out a little faster. I like this solution better because I think it's a little more concise, and I usually like trying to write code that way. So I'm not saying this is the best possible solution I came up with, but it's probably my favorite for this case. So I hope this helped you out, and thanks for watching the video.